All right, on page 1, in this first week of chapter 9, we are going to focus on square roots. Okay? Square roots, excuse me. Where's the fourth packet from there? There wasn't a fourth packet? Is there an extra? Here. Here, come on. Okay, so a little bit of vocabulary. This is called the radical. I think you know that. The number that is underneath the radical is called the radicand. I'll tell you right now, we have to get through this. So if you want to chit chat and be annoying and waste my time, you're not going to have enough time to get the last examples. So I need to do this time. Okay. This number right here is called the index. So if that was a 3, we'd have a cube root. If that was a 4, we'd have a 4th root. If there's no number, what do we assume that it is? Okay. We assume that we have a square root, okay? Okay, so I'm telling you right now, we are only going to be working with square roots. We are not going to do anything with cube roots or 4th roots or anything higher. Okay, now I want you to know the first 15 perfect squares. Okay, 1 squared is 1. 2 squared is, write them down, 3 squared. 4 squared. 16. Then 25. Then 49. 64. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared. And then I like this. 14 squared is 196. You just switch the 6 and the 9. And then 15 squared is 225. Oh. Okay. So, and what's the square root of 16? The square root of 16 is 4 because 4 squared is 16. I have a meeting. Ms. Christensen and I are going to the same meeting. We should be here. Okay, now what happens in number 2? What is the square root of 121? So this becomes 2 times 11 because there's multiplication when we don't have a symbol, okay? So this becomes 22. How about you do 3 and 4?
Oh, I did. I just got
What? Okay. Yeah, we can use calculators.
Pass those out.
It is not 103. It is 102. I'm right. Someone's on this calculator.
Gabe, what's the square root of 289?
Add 17.
Okay. In your calculator. I'm gonna go over to my picture over here. If you need to check a square root, if you press second and the square button, that'll give you a square root. And then you can push in 289. Okay. Hey, can we like not with the noise? Okay, so what's 6 times 17?
102.
Okay. Okay. All right, Ella, what is the square root of 400? Okay, so number 4 is 3 times 20.
60.
Okay. Harry, can we not with the noise? Okay. Now, that's really not the main event. Okay. We are going to be looking at square roots that do not have a perfect square underneath, and we need to be able to reduce them. Okay. So if we have a number like the square root of 20, is 20 a perfect square? Nope. 20 is not a perfect square. However, there is a perfect square that divides into 20. 4. So what we're going to do is we're going to break up 20 to 4 times 5. Okay. And what we're going to do is we're going to take the square root of the perfect square. What is the square root of 4?
2.
And then whatever the not perfect square is has to stay under the radical.
Got the answer?
Okay. Okay, just hold on. Hold on. Okay. We're going to take our number that's not a perfect square, and we're going to rewrite it as a product. We're going to rewrite it as a product of a perfect square times something. So 20 is 4 times 5. Right? Do you agree with that?
Yeah.
Okay. Why did we choose 4? Because it's a? Okay. Kari, what's the square root of 4? So that good. Yeah.
That's
Okay.
your answer?
That's your answer.
That's
It's not exact. We're not approximating, we're giving exact. Okay. But like we just leave it as 2 square root of 5. That is simplified. Okay, Maddie. Okay, so the goal would be to find the largest perfect square. Okay, if you get down to here and it's still not simplified, then you got to keep going. Okay, but if both of these are perfect squares, that means this is a perfect square and you've done more work than you need. Okay, so let's look at number 5. Okay, and I will show you a secondary method for doing this if you don't like this way. Okay, the square root of 32. Let's think of the biggest perfect square that divides into 32. Okay, 16 times what? 16 times 2. Okay. Well, hey, what is the square root of 16? The square root of 16 is 4. So I rewrite the square root of 16 as 4. But then I still have the square root of 2. Okay. Now, I'm going to show you another way in case your brain needs something different. Yes.
So is it 4 times it? Or
Yeah. 4 times square root of 2. Kind of like when we have like 4x, right? Okay. Maddie.
So I have a question. Why would we turn the 4 to 2?
Because it's outside of the square root.
How do you know sure what's inside and outside?
So whatever your perfect square is, like this is the square root of 16 times the square root of 2. So like the square root of 16, we know is 4. And then the square root of 2, that's not a perfect square, so he has to stay. Okay. Now, let's say you don't like that. what you can do is you can make a factor tree. So maybe you're like, 32. I know that that's 8 times 4. And I know 4 is 2 times 2. And I know 8 is 4 times 2. And I know 4 is 2 times 2. Okay. What you can do is you can say, oh, hey, here's 2 squared. So that comes out of the radical. Oh, hey, here's 2 squared. That comes out of the radical. And I have a loner, so he stays underneath the radical. Okay. Anything squared can come out of the radical because a square root and a square undo each other. Okay, so I'll show number 6 in both ways, and then you can decide which one you like better. Okay, so let's look at number 6. 180. Can you think of a perfect square that divides into 180? 9 times what?
20.
20 still has a perfect square though, so I need a number bigger than 9. 20 has a perfect square that divides into it. 12 is not a perfect square.
18%.
So you have a calculator, the 16, 36 times what? Okay, so 180 is 36 times 5. And what's the square root of 36?
6.
Now, it took us a little bit of time to get there. So maybe you didn't love that. So this is your second option. You take 180, and it's pretty obvious, like Kyron said, hey, this is 18 times 10. Okay, well, 18 is 9 times 2, and 10 is 2 times 5, and 9 is 3 times 3. So 3 squared comes out of the square root as 3. Oh, here's 2 squared, comes out of the square root as 2. And 5 is still under the radical, so we have 6 radical 5. Okay, this is a lot of work. But here you gotta think a little bit. Okay. So how about you try number 9? You try number 9. Ready, set, go. We don't have a lot of time. You try number 9. Henry is getting 4 radical 3. Does anybody agree with, you agree with them? Okay. So did, Zayden, did you say that 48 is 16 times 3? And then the square root of 16 is 4? There it is. Are you trying to do the tree or no?
Yeah, but I don't know what.
Can you also get 6 and 4?
Okay, so if you do 48, your tree was what? Like 6 times 8? 2 and 24? And then you did 2 times 12? And then 2 times 6? And then 2 times 3? Anyway, so here's a pair of 2s that come out. Here's a pair of 2s that come out. And 3's the loner underneath.
You've also done like 6, 4.
Yeah.
It's 4 times 12.
So no, because if you give me the answer of 2 square root 12, 12 still has a perfect square, so it's not simplified. 12 is 4 times 3. Okay, so you have to make sure that when you're reducing this, this doesn't have a perfect square. Now, what happens if there's a number in front? Go look at number 10, okay? This is just 2 times the square root of 54. So what perfect square divides into 54?
9.
Okay, 9 times 6. So what we have, we know that the square root of 9 is 3. And this is being multiplied to 2.
Will be 6 or 6.
It'd be 6 radical 6. The numbers outside can multiply together. Ah, yeah. What?
I don't know.
Which method do you like?
I don't know. I don't want to do that.
She doesn't like either method. Okay.
It's too, I don't want to do so much work. That's why I have to.
Okay. How about you and your partner do number 11? Just do it right where you are.
Twenty-five and 6. 25 and 6.
Hey. Good Lord.
How much your bench?
How much do I bench?
Yeah.
Don't know.
Too much. I didn't borrow.
Too much of the bar.
See, that's why I have splits in my shirt, because my arms are just too
I got the 35 more.
No low bar.
All right, Gabe. 150. What 2 numbers multiplied 150? 25 times 6. Okay. Okay. So the square root of 25 is 5. So when you did your factor tree, do you have 5 square root 6?
Well, I did like half of it, and then I did 15 and 10.
Okay, so you have 15 and 10, which is 5 times 3 and 5 times 2, right? So here's a pair of 5s that come out. And then 3 and 2 are loners. Well, what's 3 times 2? Okay. So our answer is negative 25 square root of 6, because we got to multiply the 5 and negative 5 out here. Okay.
Oh, well.
Okay. What I want you to do, we still need to talk about what if there are variables under our radical. So part of your homework, I said only part of your homework, just go ahead and mark it, is on page 3, number 1 through 12. Okay, so you can cross out like not 1 through 12. And then I want you to turn to page 4 for us to continue. So this is homework part 1. And we're going to turn to page 4. I know. I don't love that our class is shortened today because of MCAS testing, but it is what it is.
What do you do if, like, let's say you don't pick the highest one?
Then you just got to keep going.
So I supposed to 25. 8 can be separated into
4 times 2. 4 times 2. Okay.
Question. If it's just already.
Okay, I'm not answering homework questions. Not yet. I'll get there. Okay. Now, on page 4. Hey guys, what's the square root of 9? Okay. 9 can also be written as 3 squared, right? So Kari is saying that the square root of x squared is just x. Yeah, because this is x squared is x times x. So when we have a pair, when we have x squared, we can, seriously, just be quiet. What if I had the square root of x to the fourth? What would that be?
X squared.
How'd you get that?
Because it's divided by 2.
This would be x times x times x times x. So we would have 2 pairs of x's. Oh, what if it was like the square root of n to the 5th, like number 3? If you have an odd power, this is what I would do. I would rewrite this as n to the 4th times n to the 1st. Yes, you can just put n. And then Kari, what's the square root of n to the 4th? So this is n squared, square root of n. Now let's go down to this number 5. Oh my gosh, there's numbers of letters. It's totally fine. Watch this. This is what I'm going to do. Are you ready? Let's do this. Let's say, okay, we have the square root of 25. Let's think about that separately. Then the square root of x to the 6th. Let's think about that separately. Then y to the 13th. Because we're just multiplying them, okay? So let's think about one at a time. What's the square root of 25? Okay. What's the square root of x to the 6th? X to the 3rd. Because we would have 1, 2, 3, 4, 5, 6 x's, right? So we'd have 3 pairs of x's. Okay. Now, y to the 13th, since that's an odd number, oops, we can say, okay, let's think about y to the 12th times y, right? So the square root of y to the 12th would give us y to the 6th, and then we have square root y. What? So, okay, you guys, I cannot answer her question if you all have side conversations. I will tell you what the homework is. So the square root, so like the square root of x to the 6th was x to the 3rd, because there's going to be 3 pairs of x's. If I write out all 12 of these y's, how many pairs are we going to have? So that's why this is y to the 6th. Okay. Yeah, it is. Yes.
What would you do if you don't have a perfect square, like you said, have like 30 or something?
So let's go to number 4. Because number 4 gives us that example. Okay. Okay. So what is a perfect square that divides into 40? 8 is not a perfect square. We have 4 times 10. Then we have a to the 19th. Well, I'm going to write that as a to the 18th times a. Is that okay?
I guess.
Okay. So this is what's going to happen. What's the square root of 4? 2. And then 10 has to stay under the radical. What's the square root of a to the 18th? A to the 9th. And then that leftover a has to stay under the radical with the 10.
18 square root of 9?
No. A to the 18th means I have 18 eighths, which means I have 9 pairs. I would like you to do number 6. You do number 6, we'll go over what we done. Those are very one.
Annoying.
Where's Nico? I will give you this hint. You will end up with 3 things under your radical.
I think I got nothing outside.
There are 2 things outside of it. Yes. Well, but it would have to come outside.
Oh, so like that.
Right, it wouldn't be under the radical anymore.
Hey, so would there be
So you're gonna have q to the 3rd. No, hold on. No, you would have q to the 4th. Okay. P to the 15th. Hey, we're not moving. We're not packing up. We still have a minute and a half. We're fine. P to the 15th is like P to the 14th times P. Q to the 9th is like Q to the 8th times Q. And then we have R. So we get P to the 7th. Outside, P stays underneath. Q to the what? 4th outside, Q underneath, and R stays underneath. Stop packing up. On page 6, I need you to do 1 through 8. So you have 20 homework questions. 12 of, don't make noise. 12 of them without variables, 8 of them with variables. Now you can pack up. Please be good for my sub tomorrow. Bring your computer, bring headphones. Be ready to do a